This will be our intro to the sheet metal application on NX. We are going to use that application to create a sheet metal component. And we're going to make this bracket. Just like the other applications that we've looked at, lots of other CAD packages have a similar application. The sheet metal application helps us to create sheet metal parts. Allows us to easily design these bends and all sorts of other things. And the cool part is that when we're done with our part, we can then create a flat pattern. We can export that flat pattern as a DXF, upload it straight to a plasma cutter or a laser cutter, and cut out our 2D flat pattern, and then bend those components to create our actual part here. So remember, when we do sheet metal parts, we want to specify the gauge, but also the thickness in decimal inches, because we can say 16 gauge, but someone might have a different thickness for that 16 gauge. So we are specifying exactly what that thickness is. So we're going to be using 0.0598 inches for our 16 gauge sheet metal here. 16 gauge is what we typically have down in the shop. So we can open up NX, make sure that we are in Roll Advanced. We're going to go to New. We want to be in a model in inches. Make sure that we're saving this to a location that we can access later. And then we want to save this as LAB10A. And we'll hit OK. And we're going to go ahead and go to Application. And we want to go to Sheet Metal. It's over here beside Modeling, Sheet Metal. And we can see that we have access to a ton of other commands up here. First thing that we want to do is we want to tell NX what thickness of material that we're using, what's our bend radius, and other information that it needs to be able to make decisions. So we're going to go to Menu, Preferences, and then Sheet Metal. Again, that's Menu, Preferences, Sheet Metal. And on these global parameters, the material thickness, bend radius, relief depth, relief width, we're going to change that to the thickness of our material, which is going to be the 0.0598. And we're going to do that for all of these. Everything else is good. And we can go ahead and hit OK. Now, typically we would start with the sketch, and we could start with the sketch. We could even extrude it and then convert that to sheet metal. We could have started this in the model application, the modeling application, and we could have created some parts, even put in lines for our bends, and then we could come to the sheet metal application, convert our solid bodies to sheet metal, and manually bend our part. That is one way to do this. The other way is to start off with a tab and then add flanges as we go. You could also build a sort of mold and fit the sheet metal around that mold. We are going to start with the tab, and it's already factoring in our thickness that we have. And so it's asking to select curve. What we are going to actually create a sketch. We want a rectangle. Start at our origin. And this will be a 2x2. Sketch is fully defined. We'll hit finish. And it is extruding that to the thickness of our material. So that's why we specified that the 0.0598 so that NX knows what to put in for some of these parameters. We'll hit OK. And this is going to be the bottom face of our bracket. And now we need a bend coming from here. So if we look at it from this point of view, the bend is going to be coming out, going up. And so what we'll do is we will add a flange. It's right next to tab, we'll add a flange. And we're just going to select the edge that we want the inside of the bend to be. And so that's what this edge is going to be. Click on that. And we can see that it automatically puts in a bend. There's a couple of parameters that are being specified here. One is, so the width option, we're going to go with full. Our length is 2 inches. Angle is 90 degrees. The length reference and the inset is going to be the two things that really make or break our parts. So the length reference is going to be how we're measuring this 2 inches. So are we measuring it from this bottom face? Are we measuring it from the top face? So we can kind of see this this brown line here is what that 2 inches is measuring from. So right now we have outside. If I change it to inside, see how it moved up? It's now measuring from the inside face. You can measure from the web, so it's going to start measuring after the bend, or after the webbing of the bend. We also have tangent as well. And we can see how that affects the length up here. And if we look back at our drawing, our dimensions are based off of these bottom faces. They were measuring this 2 inches from this bottom. And we're also measuring this 2 inches to the back face of our sheet metal bend right here. That's important. That's what we'll look at next. But we want them measuring the 2 inches from the bottom of that part. So what we want is outside here. It's measuring from this bottom face up 2 inches. Now we also have control over where this bend starts. And that's going to be the inset. Right now we have inside, we have material outside. So this is what it's going to be changing right here. We have bend outside and material inside. So the material inside is where the bend is going to start, and it's going to go vertical at the edge of what we originally designed for the part. So we have this 2 inch by 2 inch square here. That's the tab that we made. And so the bend is going to bend so that when it goes vertical, it's within that 2 inch area. If we do material outside, then the bend is going to start. So the inside face of our bend lines up with that 2 inch mark. If we do bend outside, then the bend is going to start after the 2 inch box that we have. So we want material inside because remember we're measuring from the back face to the front of this part. So we have 2 inches and 2 inches, and we'll hit OK. Now we have this bend here. And before we do the side panels, let's go ahead and address the holes. So we have 4 holes on the bottom face and then 4 holes on this front face. They are centered on each of the faces. They are in a 1x1 grid here. I'm going to do it a little bit differently than how we've done it before. We'll come over here to more. So we want modeling, we want more. Then we have hole. We've got 1/4 inch holes, so we'll put in 0.25. And on the point, I want to do a sketch section. Let's do it on this face first. Hit OK. And I don't want to specify a point. What I want to do is I'm going to go to rectangle. And I'm going to go ahead and make this grid, this 1" by 1" grid. And then I'm going to center it on the face. And I'll have my 4 points for the holes. I'm just going to make this rectangle. I want this to be 1" by 1". And I want this to be centered on the face. And the way that I'm going to do that is I am going to use our make constraints. What I'm going to do is a make midpoint aligned. I want to choose our motion curve first. So this is the line that's going to be moving. And I want to choose the midpoint of this line. If you cannot find this midpoint, come up to your filters and make sure that you are within work part only, not within the active sketch. Make sure that you are within work part only and select this midpoint. Don't select just a point on the curve. It'll help to turn off the point on the curve. Now all we want is the midpoint. We'll hit apply. And we're going to do the same thing for the bottom edge. So I'm going to choose this line here, the bottom of our rectangle, and then the point that I want to be stationary is going to be the midpoint of this bottom line. And I'll hit OK. Now our sketch is fully defined, but what I want to do is I want to turn all these lines into reference geometry. And then I'm going to come up here to point, and I'm going to put 4 points, 1 on each of the corners. And we accidentally turned our dimensions into reference geometry too. Not what we want. I'm going to turn those back into driving geometry so that our sketch is fully defined. And I'll hit finish. And now we have our 4 holes for this bottom face. Make sure that we are going through body and that we're subtracting. And we'll hit OK. And then we'll do the same thing for this top face. Make the holes. We've got our 8 holes. Now we can start working on these triangular pieces that are coming into our bracket. Now, the bracket, what'll happen is once we make the bends, we have got 3 bends here. We've got 1 at this bottom corner, and then we've got 2 on the side. And once we have those bent, we can then lay down a weld on the 2 edges and have a solid bracket. So sheet metal and welding kind of go hand in hand for a lot of different projects. And so to make those bends, we'll come back up to flange again. And this time I want the flange to be coming here. We're going to leave the same parameters that we had before. So outside and then material inside. And we will hit OK. And I don't like how we have this gap down here. There's not really a good transition here because all we've done is we've just taken this line and curved it. So the line ends right there because of the bend. But we can create a corner. So if we come up here to closed corner, close and relief, And we can select the corners that we have here. And we're going to be able to adjust how this corner kind of closes up right here. We have it open right now. We could do closed. But what I like to do is do a circular cutout. And well, we'll see why whenever we do our flat pattern, but this is going to help us out to actually create these bends. Overlap is fine as none. And what that has done is that is added material to the flange that we just made so that it actually makes a corner on this bottom tab. And it looks weird right now, but when we go to show results, it actually makes it one solid piece. And that's what we want. So we'll hit OK. And we'll do the same thing for the other side. Make a flange. Make sure we select that edge. Those parameters are good, so we'll hit OK. And then we will add another closed corner. Select our corners. We still want a circular cutout, and we'll hit OK. So now we need to cut out part of this corner piece. Now, typically we would go to a sketch, and we'd sketch on this, and then we'd maybe go to extrude, and we'd remove that material. We are going to do something similar, but we have this command here, normal cutout. And that's what we're going to use. And for the section, we're going to actually go to the sketch. And I'm going to select that face. Hit OK. And so on the drawing, our line is from the top edge of our part to the bottom edge. So it kind of like splits right where that bend is at. So I'm going to go to line. Make sure that I'm in entire assembly because I actually want to select the edge of this flange. I want to make sure that I actually get a starting point right there. And then I'm going to come all the way down to the edge of this line. And I want to make sure that I get that. See how that highlights that line? That's what I'm looking for right there, the edge of the tab. And that's where our line crosses. But remember, we want to have 2D, a solid boundary. So I'm going to continue and create this boundary. I'm going to go up and make a triangle here. And that's the triangle that we're going to remove. So again, I'll come down here and I will select that point. And then I'm just going to make sure that I have a vertical line, and I'm going to go past the sketch origin that we have. And I'm going to do the same thing over here. Make sure that I get this endpoint. Make sure that I have a horizontal line. I'm going to go past sketch origin and then just trim these. Now we have a solid boundary. I'll hit finish. And the cutout command, we have a couple of methods that we can use. We want to use thickness, and we can use until next. So it's just going to take away the thickness of that material for us. We'll hit OK. And I want to mirror this feature. So I'll come over here to mirror feature. The feature that I want to be mirrored is that cutout. Can't really access it here, kind of can there. But if we come over here to the part navigator and just select the cutout, that's what we want. And we want to specify a plane, but we don't really have a plane to mirror across. We want a plane that's right down the middle here. So we want to make sure that we have new plane selected. And we'll go to the plane dialog. And we will create a bisector plane. And I'm going to choose the tab that's right here. and then the tab on the other side, because I want this plane to be right down the center. We'll hit OK. Make sure that we have that plane selected, and we can go ahead and show results. And now that cutout is being applied to the other flange, so we can hit OK. Just double check to make sure that all of our sketches are fully defined. And there is our part. Now, how to take this to a plasma cutter. We can't just export this and upload the part file. What we want to do is we want to create a flat pattern. So we'll come over to the top right, and we want to go to flat pattern. And it's going to ask us what face we want to be upward. So the stationary face. And we want the tab that we made. So this is the face that's going to be up. Select that. We'll take all the defaults and we can hit OK. And you kind of saw it there for a second and then it went away, and it's telling us the flat pattern is created in the separate flat pattern view labeled flat pattern number 1. And we'll hit OK. And if we come up to our model views, we have a new view labeled flat pattern. We make that our work view. We can see our flat pattern here. So this is, it's taken our 3D, our sheet metal part that was bent, and it's flattened out all the geometry. So we have the tab that we first made, and then we have the bend, or we have the flange, and we have the 2 flanges coming off of that. The reason that I did the circular cutout is because of this circle that's created. It's going to help you to line up your bends better. You can kind of see the bend is going to be where this arc is the highest. Same thing on this side. And as you bend this, it's going to bend that corner easier. And we have a lot of information on just this flat pattern right here. Still, though, this is not what you want to be uploading to the plasma cutter, because we have all these lines. And remember, when we upload a DXF file to the plasma cutter, and if we were to just hit go, it's going to cut every line that it sees. So it'll do all these circles, and then it'll come and follow this line. And ideally, we want it to just cut around the perimeter. But we have all these lines in here, so it's going to cut along this line, this line, this line, that line, this line. Every line is going to have, as if we're taking a pair of scissors and cutting out these shapes. That's what the plasma cutter is going to do. So we don't want more lines than we want cut. So what we'll do is we come up to export flat pattern. And this is where we kind of have some control over what gets exported out. We do in a DXF file, go ahead and specify the name. So we can do the bend up center lines, bend down center lines, the interior cutout curves. We want to export this as an R12. I like to keep the bend up center lines and bend down center lines because I'll typically open this up in AutoCAD and make some other adjustments to these before I actually send them over to the plasma cutter. But those have more to do with some of the behaviors of the plasma cutter and just the setup that we have downstairs. So those things aren't necessary for creating a good flat pattern. So we'll hit OK. And you can kind of see it, you saw it there, how that looked with all this information removed. We just had the center lines, the perimeter, and the inside geometry. Make sure you name that DXF file the correct name that's from Canvas and submit that and your part file to the Dropbox.